Hello everyone. Welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Hello everyone, welcome to Scholar Lab. Welcome to the fascinating world of magnets. In this simulation, we'll explore the mysterious and powerful properties of magnets that have captivated the scientists and inventors for centuries. From understanding the concepts to diving into the advanced concepts like magnetization and demagnetization, you are about to embark on a magnetic journey that will pull you with every discovery. Let's get started. Let me open Fun with Magnet simulation for you. Each simulation begins with a game plan. This outlines the procedures, observations, and learning of the simulation. Our main objective of this simulation is to understand the magnet and its different properties, and also to explore the poles of the magnet and how poles occur when a magnet is cut into different pieces, and also to explore the effect of heating, beating and current on the magnet, and how an iron piece can be converted to a magnet. Let's get started. Here we have 4 important parts. Before getting into the concept, I would like to show you our physics lab in 360-degree angle. By using your mouse cursor, you can click, hold and drag and view our beautiful view of our physics lab. Or else you can click on this bottom right button to view that in 4 different angles: T for top, F for front, R for right and L for left. Let's start with the basics. What is magnet? Here I am having a plastic cup, bar magnet, paper and a paper clip which is attached with the rubber butt. Let me place the paper cup on this stand. I am placing the bar magnet inside the plastic cup and I am placing the paper to close it. Watch closely as I drag the paper cup down towards the paper clip. Is magically pulled towards a magnet inside the cup. This is a magnet attracting the paper clip. This is a magnetic material. It is like an invisible force pulling objects together. Isn't it fascinating? Let's move on and let's see what happens when we place a magnet on some iron nails. Here I have bath magnet and some pins. I'm going to place that on the pin. So let's see what happens. You can notice that how the nails are attracted to the ends of the magnet. These ends are known as the poles of the magnet. Magnet always have 2 poles, one at each end where their magnetic force is strongest. These poles are the heart of the magnet's power. You can click on this button reset to repeat again to do the simulation again. Let's move on to attraction and repulsion. Here we have 2 activities to be explored. Activity 1, where I am going to place the magnet beside to each other. I am moving this magnet north pole to the another magnet south pole. It attracts, which proves that the opposite pole attracts. Let's do that again. Let's reset the experiment and do that again. Now I'm changing the pole of the magnet by clicking on this button. Now I'm going to move this magnet towards another. Now the south pole is facing the another magnet south pole. Let's see what happens. Same poles repel each other and the opposite poles it always attracts. Let's do activity 2. Here I have a cutter. I'm clicking on it to cut one of these magnets. What do you think will happen? Watch as I slice the magnet. No matter how small the magnet pieces are, each of these one still has a north and a south pole. A magnet never can have two north poles or two south poles alone. Let's move towards the another magnet. Since this is the north pole, it attracts toward the south. Let's redo this experiment again and let's check it with another pole. Now I'm going to swap this magnet and moving it towards another one. As you can see, it repels. Let's go to the next part of the simulation, that is playground, where the theory meets the real life application. Let's find the poles of the magnet. Here I'm having a float where I'm going to place it on the water. Now I'm going to place the bar magnet on the floating object. Watch how it automatically aligns from north to south, just like a natural compass. The pole of the magnet is not mentioned here. Did you notice that? Now the question is that which is north pole and which is south pole? With the help of magnetic compass, we can answer to this question, which is north pole. Let me click on pole A. Yeah, that is correct answer. A is facing towards the north side of the earth, that is north pole. And the B, which is south pole. Let's move on to the second part of the playground, where we are going to find the direction of sunrise. In this magnetic compass, we don't know which direction that is showing. With the help of magnet, we are going to find the direction of sunrise. As you can see, the magnet is mentioned to north and south pole. By clicking on it, I am going to shake it. And the direction is mentioned in north and south. Now we are going to align this magnetic compass in the direction of sunrise. By clicking on these arrows, look at it over here, the bottom of your screen, you can alter the arrow mode. I'm going to mention this direction as my east side, where the sun will rise. Yes, that is correct. You can also redo this simulation by clicking on this reset button. Now, let's move on to the advanced topics of this simulation, that is magnetization and demagnetization. Let's talk about the magnetization first. Here we have two activities. One is by rubbing, another one using electricity. Let's start with rubbing. Now I'm going to place this bar magnet on the iron slab and I'm going to rub this using this slider over here. I'm going to rub the magnet on the iron slab until the iron slab is getting magnetized. As you can see, few of those nails are getting closer, are getting attracted towards the iron slab. Let me rub it again. Now it is fully magnetized. Let's move on to how we can magnetize the object using electricity. Let's create a temporary magnet using electricity using this circuit. I am setting up a switch connected to a battery and wrapping copper wire around the iron rod. When I turn the switch on, the electricity flows through the wire Now the iron piece becomes magnetized. As you can see, the timer has started. We need not to wait much time because we are using this time lapse in the simulator. As you can see, the iron rod got magnetized and the pins are attracted towards the iron rod. However, once I stop the electric current, the magnetic property is lost. It's like turning a magnetism on and off with the flip of a switch. Let's move on to the next part, that is demagnetization. Here we have three activities to explore: heating, hammering and electricity. Let's start with heating. Here I am having a bar magnet. I am going to click on it to attract the pins on the floor. Once it is attracted, I am going to heat that using the candle. After a few minutes, watch the candle and the bar magnet closely. The nails will fall away. The nails are fall down because of the magnet is heated strongly. It loses the magnetic pull. Now I am going to place this magnet in the water to cool down. Let's see how the magnetic property works now. After rubbing it with another bar magnet which is cold, it regains its magnetic property again. As you can see, by clicking on it, it attracts the nails again. Let's move on to hammering. Let's see what happens when we hammer the magnet. Here I'm clicking on the bar magnet to attract the pins. And I'm going to place it under the hammer. Now I'm going to turn on the machine to hammer it well. The nails are fall off, showing us that when a magnet is beaten or dropped from the height, it loses its magnetic power. Let's move on to the third part, electricity. Here I have a copper wire which is coiled on a iron rod and the pins are attracted towards it. As you can see, when an altering current is passed through the magnet, it also loses its magnetism. Electricity can both create and destroy the magnetic properties like a magic. And the fourth part of the simulation, we have quiz to test the kids' knowledge, how much they have understood about the concept. Here we have set of 5 questions and all 5 questions need to be answered before hitting on the submit button. After answering 5 questions, hit on submit to check your scores. And also you can click on check answer button to check what are the answers are right and what are the answers are wrong. And also you can click on this explanation button to view the explanation of the question. And that is the wrap of our magnetic adventure. You have just uncovered the wonders of magnetism from the basic concept of attraction to advanced concepts. Magnets are all around us, playing crucial roles in everything from navigation to powering our modern world. Whether you are creating a temporary magnets with electricity or demagnetizing them with heat, now you have a deeper understanding of invisible forces that shape our world. Thanks for watching.